Hello students, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve these two problems which says that express the moment of the couple acting on the frame in Cartesian vector form. The forces are applied perpendicular to the frame. What is the magnitude of the couple moment? So these forces are applied perpendicular to this frame. So if we look into this frame from the y-axis is from this direction, so we will be able to see the frame, this edge of the frame. So we will be able to see it like this. So this will be our x-axis, this will be our z-axis, and if we look into this from this direction, so the y-axis will be out of the screen. So now the forces are perpendicular, so we can show that this will be F and this will be minus F. So, and we are asked to represent the the moment of this couple as a Cartesian vector. So as we know that the couple moment will be lying in a plane which will be perpendicular to these two forces. So as we know that this force, it is given that these forces are acting perpendicular to the frame. So the couple, the moment produced by both of these forces will be parallel to the frames. So we always know that the moment produced by any force always lie in a plane which lies in that particular plane which is perpendicular to that forces. So now these forces are perpendicular to the frame, so the couple they are producing will be parallel to the frame. So we can say that there is the couple moment will be parallel to this frame, and let's say that this is MC. Now we can find MC by applying that formula. We can find the magnitude of MC. So the magnitude of MC will be this force times the perpendicular distance between both of these forces. So we can say that the perpendicular distance is 1.5 times F, and if the forces are given in Newton, so this will be in Newton meters. So now this is the magnitude of the moment produced by these forces which make a couple. So we can say that this MC is equal to 1.5 times F. So now, and this is that vector of MC, right? So we can say that this is MC vector. So if the frame is making 30 degrees with the x-axis, then that moment of the couple is also making 30 degrees with the x-axis. So we can resolve this MC into its component. So we will have one component of MC. We will have one component like this. This one will be the MC cos of 30, or we can say that this is 1.5 F cos of 30, and we will have one component like this. This one will be MC sine of 30, and this will be equal to 1.5 F sine of 30. So now we can say that MC, we can represent that MC as a Cartesian vector. It has two components. Its Z component, its Y component is 0. Since this component is along the negative x, so we will write that minus 1.5 F cos of 30. This is in the negative I, and we have this component, this is in the negative K, and its J component is 0. So we will write that plus 0J minus 1.5 F sine of 30, and this is in the negative K direction. So this is minus K and this is minus I. Now in the first problem it is said that take F is equal to 50 Newton. So if we substitute F is equal to 50, so we will get that MC Cartesian vector. So this will be the solution of 488. So this is equal to minus 1.5 into 50 cos of 30I plus 0J minus 1.5 into 50 sine of 30K. So 1.5 into 50 multiplied by cos of 30. So this is equal to minus 64.952I plus 0J, and then sine of 30. So this is minus 37.5K So this is the solution of 488. This is the Cartesian vector representation of the moment of these two forces which are making a couple. And similarly, in the problem 489, it is said that in order to turn over the frame, a couple moment is applied as shown. If the component of this couple moment along the x-axis is minus 20I, determine the magnitude of the couple force. So we will use this generalized Cartesian vector. So we are given that mx, the x component of the couple moment, is equal to minus 20I. So we are given this. So we can say that from this we can say that minus 1.5 f cos of 30 is equal to minus 20. So we can say that the solution of problem 489, so for that we can write that minus 1.5 f cos of 30 is equal to minus 20. There's no need to write I, so minus will cancel out, and we can say that f is equal to 20 divided by 1.5 f cos of 30. So that is equal to 20 divided by 1.5 cos of 30. So this gives us 15.40, let's say 15.40 newtons. So in order to turn over the frame, if the x component is minus 20I, then the force, the magnitude of both of these forces is 15.40 newtons. So this is the solution of these two problems. I hope it will help you in your learning. Do subscribe Engineers Academy for such more problem solutions from Hibbeler Statics.